All right, hello there. This is Garrett with another video on the Cortical Labs CL1. I'm super excited to be sharing this with you today. And we've actually had some custom code that we've added into this. So if we look CL04, real-time visualization, which is going to be a very important thing, when it comes to doing a lot of different types of games. So if we go through and we start looking here, um, we look at cl.visualization.jupyter import display visualizer. We use this in an earlier tutorial, and it is importing, HTML file and a JS with gameplay and spikes. Now, I want to be upfront here, that those files are right here. I was having a small issue with it, so I ended up doing an alternative implementation down here with matplotlib. So that's just another way that you can kind of get under the hood and do it. Although, this should work. I think it's just a problem with my browser. I probably need to clear my cookies or something. But nonetheless, all of the logic lives within the code. So when we run this, that does bring up this visualizer right here, and you'll see gameplay and CL spikes. And then if we come down through the kind of the initial code here, this is where the real action happens, so the original Pong game that Cortical Labs is famous for, um, is actually kind of, the logic for how that ended up working on the system happens here, so this is a very, very interesting tutorial. And what we're doing here is actually, we're importing CL, the random package, and math. We're going for 5 seconds. We're also going here through the tick delta, defining the size of the game, the ball speed, the speed that the ball moves, height and width as well. And then, we come down and define the game. So as we define the game, it's important to notice, we're using a data stream. So that's how, kind of the cornerstone of how the Pong game or any game works to feed into it is data stream. So we start with that, and then we come down here and we are basically building out, a ball starting at a random position, picking a random angle, splitting into X and Y axes, and then, also using, I believe, cosine and sine here for the velocity components. And then, the bounce axis, comes down here and, we define, how the ball bounces back and forth, in the typical game of Pong. Um, basically this updates, so if the game state has changed, since the last tick, we append an update to the data stream. And down here, we create a recording of our game, which will include the data stream we create below, and we create a recordable visualizable data stream, which is what you will see in a minute. And we'll come down and kind of handle that separately in matplotlib. So when we come down here to matplotlib, you could see a lot of the exact same concepts, cosine, sine, XY axes, the duration, the size of the ball, etc. But we're doing this inline here, basically in the browser, and it creates this this right here, this little game of Pong where the ball will bounce back and forth. And I've also, there's some other things where it will play backwards. You can make it play one time through. So, this is, just an interesting thing. I would say refer back to the data streams tutorial if you really want to understand in a greater sense, that, kind of, the big thing here, the big thing that's going on, is data streams, us using and appending data streams, as the cornerstone of, a game, how the game updates, how it plays, and, how the neurons essentially can play a game, like Pong, or they could play a different game like Doom. They could play Minecraft, which is a demo that I did. Not very well, in some cases with the games, but we will actually be showing you how to, kind of improve and extrapolate on top of the learning that you find in your experiences with data that comes from the device, and you actually can get really great performance out of games. Um, if you hone in on your data, because that's what I really want to be clear here on is, to have this device play games well, you have to have good code, but you have to also hone in on how the device works, proper rest cadences. As I've found, it's with any machinery in the world, and this is probably some of the most complex machinery out there. If you're good to the culture will be good to you. So in the next, we will be going into reading raw data, which is super, super important when you're trying to make a game and make your game play well. All right, thank you very much.